Yes, can all of you see the shared screen?
Yes, sir.
Okay, so let's start. So let's continue with concurrent force system, and we have started. We have derived the method to find out the resultant of the concurrent force system. So let's continue with the next example. So I will just read the question. A striker of a carom board laying on the board is being pulled by 4 players as shown in the figure. The players are sitting exactly at the centers of the four side. Find the resultant forces in magnitude and direction. Okay? So first thing we need to do is find out the angles. To find out the angles, make these triangles, and we need to know the sides of each triangle.
सर आपका वॉइस क्रैक हो रहा है.
How about now? Is it still cracking? Hello.
No sir.
Okay.
No
Right.
sir.
So let's find out all the angles. So to find the angles, we are going to use the trigonometry. So first we need to find out all the sides. This is 300 mm. This will be 100. This will be 500. Height again here will be 150. This will be also 550. 550. And this will be 100. Okay. So let's find out all the angles one by one. So first, let's call this as say alpha. So alpha is equal to tan inverse of 150 by 300. Let's call this angle as beta. Beta will be tan inverse 100 by 550. Let's call this as gamma. Gamma is tan inverse 150 by 100. Let's call this as theta. Let's call this as phi. Theta might be used somewhere. Phi is equal to tan inverse 100 by 50. Okay, so calculate all the angles.
Sir, how did you get the value of 100, 550, 500, 150?
So I'm using this triangle. See, I'm constructing this triangle. Okay. All right. So these are all midpoints. All A, B, C, and D. These are all midpoints. Okay. So total is 800. So midpoint means half will be 400. Okay, and 300 is given over here. So 400 minus 300, that is 100. So similarly, here also 400, 400 minus 250 is 150. Again, here is 400, 400 minus 250, again 150. Here it is 100, here it is 300. So again 400 minus 300, 100. And since this total is 800, this is 300. So remaining is 500. Like that I have subtracted and calculated.
Okay, okay.
So I will just write the angles, you verify. So alpha is 26.56 degrees. beta is 10 point
Sir, beta is 10.30.
10.30, correct? Gamma
Gamma is 16.69.
16.69 or 16.70, I rounded off. And phi is
22.19.
it's slightly different, 21.8.
21.08.
Correct. That is the correct. Okay. Now here all the angles are with respect to horizon. So what I will do, you can use this angle also, or I just have subtracted this one by 90 degrees. So this is beta is 10.30. So 90 minus beta, that is what I have used in my calculations. So I'm just going to write it as 79.70 degrees. Okay. So these are all the angles. Okay. And this one also, because I am going to and also phi, I have also done that 90 minus 5. So that is equal to 68.19. Because I want to do all cos or all sine just to avoid calculation mistakes. Because when I'm resolving with x-axis, I want to do all cos, and I'm resolving with y-axis, I will all do sine. Okay, so that's why I have done this. You can, it is not necessary, but it's up to you. But just for sake of convenience, I have done it. So these are the 4 angles. Now we have to find the resultant. So to find the resultant, what we are going to do, we are going to resolve all the forces. So and for resolving the forces in x direction, I'm going to write the equation summation fx is equal to taking right hand side forces as positive. So that will be one by one. I'm going to resolve the forces starting with this 20 Newton. It will be 20 cos 16.7 plus 15 cos 68.19 minus 10 cos 26.56 plus 25 cos 79.7. Okay, so this is summation fx. So calculate and tell me the value. Similarly, summation fy upwards positive is equal to 10 sine 26.56 plus 20 sine 16.70 plus 25 sine 79.70 minus 15 sine 68.19.
$20.25.
20.25, correct. Summation fx is 20.25. Summation fy.
Sir, why did you subtract minus 10 cos 26.56 and minus 15?
Cosine component of 10 will be this way, right? This will be 10 cos 26.56. Okay, so we have taken the convention, all the forces in the right hand side are positive. Okay, so this comes from the left hand side.
Okay, got it.
Similarly, for the 15.1, the sine component is coming downwards. This is 15 sine 68.9. While when you resolve and we have taken the convention, upwards is positive.
Okay.
Sir, how did you mark that arrow downwards, upwards in the given figure?
Means why did I mark it in this way?
Yes, sir.
Because it is
That
given.
arrow.
It is given, na? It is being pulled by the four players. Okay, so four players are sitting at the center of the carom board and they are pulling. So the direction of the force will be towards the player.
Okay, sir.
20.88.
20.88, correct. I have rounded up it to 20.89. Okay. Right. So you have got summation fx, summation fy. Now let's calculate the resultant. So R will
Sir, can
be
you go on the previous slide? Thank you, sir.
right. So resultant will be summation of fx square plus summation of fy square, and that is equal to 29.09, and theta will be tan inverse of summation fy by summation fx, and that is equal to I should not have given this answer. Just calculate and verify.
Sir, can you scroll a little bit up?
Scroll.
Yes, scroll.
You want me to go to the previous slide?
Yes, sir. Okay, okay.
Done.
Yes, sir, yes.
Angle is 44.10.
Correct. 44 point. I'm getting it slightly different. 45.89.
Sir, 45.89.
45.89.
Okay. So resultant is 29.09. All of you have verified this value. Newtons, and angle is 45.89. So your summation fx and summation fy both are coming positive. Okay. By using whatever sign convention we have used, so both are coming positive. So the resultant has to lie in the first quadrant. So your resultant, if I on this board, resultant will be, this is the resultant R, that is equal to 29.09, and your angle will be 45.89 degrees. So this is how you can represent your final answer in your diagram also. You can make this arrow slightly thick to differentiate with the other force. All right, next one. Done. Can I go to the next one?
Yes, sir.
So, 5 concurrent coplanar forces are acting on a body as shown in the figure. Find the resultant of the 5. So what we are going to do, we are going to resolve these forces. So I'm going to write the resolution is 20 cos 64, 20 sin 64. 14 cos 60. 32 sin 58. 32 cos 58. 28 cos 18, 28 sine. Right? We have resolved all the force. 23 kilonewton. There is no need to resolve. It is already along the y-axis. Okay. So now let's write the summation equation. Summation fx. Again, I always use this convention, right hand side positive. I'm going to use that. So that is minus 14 cos 60 minus 20 cos 64 plus 32 sine 58 plus 28 cos 80. Okay, so calculate, and summation fy is equal to upwards positive is equal to 14 sine 60 minus 23 32 8 minus
Sir,
28
125
just a
summation.
minute, sine 18 minus 20 sine. Yes, tell me now. Summation fx?
1.25.
No, no. There are these two are
37.99. 38.
38 kilonewtons. Correct. And it is a positive value, so it is in the right hand side.
Sorry, sir, I didn't saw the sign of the forces. Sorry.
That's okay.
Minus 20.54.
Minus 20.54. Okay. So here you are getting a negative sign. Five. I have rounded it off.
Sir, fourth quadrant.
Yes. Now, so that means what? Summation Fy is 20.55 kilonewtons. And we have assumed this upwards positive, but it is coming negative. So this is in actually downward direction. Okay. So your summation Fy is in a downward direction and summation Fx is in right hand side. So your resultant is now in the fourth quadrant. Let's find out the value of this resultant. Resultant will be somewhere in the fourth quadrant.
Sir, sir,
Yes.
43.20.
Let's calculate. Let's see that. So R is summation square root of summation fx square plus summation fy square, and theta is tan inverse of summation fy by summation fx.
28.40, sir. Theta.
Theta is
Sir,
28.
resultant is 43.20.
Resultant is 43.20. Correct. 43.20 kilonewtons. So this is how you represent the resultant. R is equal to 43.20 kilonewton, and angle is 28.240 degrees. All right. Any questions?
No, sir.
No.
Okay. Let's go to the next one. R is equal to 800 newtons is the resultant of the four concurrent forces. So this is the resultant which is given. Find the fourth force. Okay. So here they have asked you to find the fourth force. So let's call this as F4, F1, F2, F3, and F4, and let's assume that this is in the first quarter. We don't know exactly where it is. 4, and it makes an angle. So let's do summation fx. Right hand side positive. So that is equal to 400 cos 45 minus 300 cos 30 minus 500 cos 60 plus f4 cos theta. That is summation fx, and summation fy upwards positive is equal to 400 sine 45 plus 300 sine 30 minus 500 sine 60 plus f4 sine theta. And this whole thing is equal to the cosine component of the resultant, that is 800. So it will be 800 cos 50. This will be so this is the 800 cos 50. It is in the right hand side, so it is aligned. So this is taken as positive. Okay, and summation fy, we have taken this as upwards positive, and so resultant is in downward direction. So this is 800 sine 50, that is equal to minus 800. So find out the value of f4 cos theta and f4 sin theta.
Sir, how 800 cos 50?
Because we have to result, this is resultant is given, na? Resultant is already given. Okay, and the fourth force is unknown, f4, that we have to find out, and it's 800 newtons. So I have resolved that 800 newtons in horizontal and vertical direction. Okay, so horizontal component.
Sir, why did you take a f4 a positive?
Because I have assumed f4 to be in the first quarter. This is an assumption. Okay, if I get a value negative, that means the position I have to correct.
Sir, it is f4 cos theta is minus 0.85.
No. Check your answers.
Sir, 287.26.
No.
Sir, 741.23.
Correct. I am getting it slightly different, but it is almost correct. So F4 cos theta is 741
19.
correct. That is the exact answer I am getting. And it is coming positive, so it is in the right hand side. Okay, so this is positive. Okay. Similarly, tell me F4 sin theta.
Minus 612.67.
Correct. Minus 612.666 newtons. And it is coming negative. So this 612.666 newtons is in fact in the downward direction. Okay. So your is in fourth quarter. F4 is in fourth quarter. And theta will be tan inverse of 612.666 divided by 7.19. This is 741.195 Newton. 19. And this is 612.66. Find out theta.
39.576.
Correct. 39.58. Correct. Okay. These are the final answers. Okay. So now, so far we have studied the concurrent force system. Now next go to the let's go to the next type of force system, that is non-concurrent, non-parallel force system. Okay. Now before we start with this non-concurrent, non-parallel system, there is one concept we need to understand, that is of the moment. Okay. So to calculate, so what does the moment do? Moment on a body tends the body to turn or rotate. Okay. And it is simply defined as the product of force and perpendicular distance between the line of action of the force and axis of rotation. Okay. So for example, if this is a irregularly shaped body and a force F is acting upon it. So now if you want to find out the moment of the force acting on this body at point 0.01, then that moment will be given as force into this perpendicular distance, that is d1, and this moment will tend to rotate this body in the anti-clockwise direction. Okay. Now if you want to similarly calculate the moment of this force about 0.02, that is you fix 0.02 on the body and calculate the moment, then this moment will be given as F into d2, and now the moment will be in the clockwise direction. So depending upon where you fix, at what point you fix the body, the moment can be counterclockwise or anti-clockwise or clockwise. Now there is one more, any questions? So this is simple. Now there is one more concept called as couple. So when couple is formed by two parallel forces of equal magnitude and opposite direction, okay, separated by a finite distance, magnitude of the couple is given as force into the perpendicular distance between these two parallel. So in this case, it will have a pure rotational effect, okay, pure turning effect, and because the resultant of this force system will be zero. Okay, resultant of the force will be zero. Resultant moment will be force into the perpendicular distance. So this is a slightly derived concept of moment. Okay, so these two things you need to know when you are calculating the resultant of a non-concurrent, non-parallel system. Okay, so let's do a small example and calculate moment of and try to calculate moment. Okay, so I will just read. Any questions? Whatever I explained on the earlier side. Oh, if you have any questions, please interrupt me and ask immediately. Okay. So a 90 Newton force is applied to a control rod AB as shown in the figure. Knowing the length of the rod is 225 mm, so this is 225 millimeters. Determine the moment of the force about point B. Okay, by resolving the force into its component along AB and in the direction perpendicular to it. So let's find moment. First, let's resolve this force. Okay, so this is 25 degrees. This is 65. So this total angle will be alternate angle 65. Okay. So this small angle will be 65 minus 25. So that is equal to 40. Right. So now resolve the force along the rod. It's a different color. And perpendicular to the rod. So that will be, this component will be 90 cos 40, and this will be 90 sin 40. Now let's calculate the moment about B. A summation M about B is equal to force into perpendicular distance. And we are going to now assume a sign convention. I am going to assume this is clockwise is positive. The moment at B will be only because due to this 90, the sign component. Okay, because the cos component of the force is passing through B, so it will not cause any moment because the perpendicular distance between B and the line of action of 90 cos 40 is 0. So summation M about B is 90 sin 40 into length of A. That is 90 sin 40 into 225 divided by 1000. Now you here have to don't have to convert, but if you keep the unit same, then accordingly you have to write the units at the answer also. Generally practice to 13 point. Yes, 13.02
13.02.
Newton. That is the moment, and it is in clockwise side. It is positive. Right. Any questions?
Sir, can you please explain again why 90 sin 40 you taken?
See, I have resolved this force into two components, right? 90 cos 40 and 90 sin 40. Okay. The angle made by the 90 Newton force with the rod is 40 degrees, right? Now the 90 cos 40 component, if you see, extend the line of action of that force, it is exactly passing through this point B, right? So the perpendicular distance between 90 cos 40 and B is equal to 0, right? So force into perpendicular distance, our equation for 90 cos 40 into 0 will be 0, right? So 90 cos 40 does not contribute to any moment, right? So only component which will contribute to the moment is this 90 sin 40. So perpendicular distance is AB, component of the force is 90 sin 40. So 90 sin 40 into A. Does that
सर
clarify?
सर डायरेक्शन वाला नहीं समझा.
Which one?
How to take the direction, positive, negative.
See, I have assumed, see, if I see this force 90 sin 40, this will tend to rotate this rod along the direction of the force, right? In this direction. Okay, this will be the direction of the moment. So if you see this direction,
Sir, can we apply right hand thumb rule over here?
No. Right hand thumb rule is a different thing. That is not required actually. Here you have to just see in which direction. See, now here you have to see in which direction the body tends to rotate, the force tends to rotate the body about the axis. So here B is the axis of rotation, and if you see this applied force, that will tend this body to rotate on the direction of the arrow which I have marked, and this arrow is marked in counterclockwise, in clockwise direction. So this is clockwise.
Sir, if the 90 Newton force will be on opposite side of the rod,
Like
so
you
it will
in,
be negative, no? Means
say it is like, oh yeah, this 90 Newton
Okay.
is, so this is 40 degrees. Then 90 cos 40 will be along the rod. The sine component will be in opposite direction. Now this force will cause the rotation in the opposite direction.
Yes, sir.
It can, in that case, it will be counterclockwise or anti-clockwise.
Okay, sir.
Oh, any other questions? Okay, now let's see how to calculate the resultant of a non-concurrent, non-parallel force system. So to calculate the resultant, again you have to resolve all the forces along x and y direction. For example, if there is this force F1 and it makes an angle θ1 with horizontal, then x component will be F1 cos θ1 and y component will be F1 sin θ1. So in that way, all the angles will be given, and you have to resolve all the forces in x and y direction. Then apply summation fx and summation fy. Again, apply the sign convention. Right hand side is positive, upwards is positive for summation fy. This is for summation fx. Summation f. All right, and calculate the resultant by using the same method, that is summation fx square plus summation fy square. And theta will be tan inverse of summation fy by summation. This is your summation fx and this is your summation f. Right. And now if when I calculate this, so say let's assume you get calculate the summation fx I get it positive, and summation fy I get it negative. All right, so the force will be in this direction. This will be the direction result. Okay. And I calculate the moment about the origin, summation m about origin, and I get that assuming clockwise positive, and I get this as a positive value. Correct. So I have to place this force R along this direction, and it should create a clockwise moment effect on the origin. It should turn this plane in this clockwise direction. So I can either place it above or below, but if you place it here, then the moment will be in the opposite direction, counterclockwise. So this is not correct. All right. So that is why I have to place it above O, so that this moment is in clockwise direction. Right? Because I am getting a clockwise moment over here. So this thing will be more clear when we solve the examples. Any questions? So let's do some few examples, and on the force. So first question. Any questions for the from the earlier side? Oh, all right. So next question: replace the force and couple shown in the figure by a single force. Okay, so this is a couple shown, and you have to replace it by a single force. That is, you have to find the resultant. The other way of saying find result. Okay. So summation fx, calculate summation fx and summation fy. So summation fx will be 0. Summation fy will be what? There is one force in downward direction, so it is
100 into 2.
no, only one force, no, 100 Newton force. Okay, so it will
Okay.
be 100 newtons. 100 newtons, and it is in downward direction. Now I am not applying here sign convention because it is a simple system. Okay, so we are already. So what will be the resultant? Square root of summation fx square plus summation fy square, and this is already 0, so it will be simply summation fy, and that is equal to 100 newtons in downward direction. Now find out the what you say moment about. So let's take let's consider this coordinate axis. Now the dimensions of this t are not given, so we are going to neglect the dimensions. We are going to take this as origin. So O is the origin. So let's calculate moment about O, and let's say it is clockwise. So one by one, let's calculate the moment. So let's the moment of 100 Newton force will be 100 into 2, and it is in clockwise direction, so that's why this is positive. Now these two forces, 50 Newton forces, are actually these are forming what is we have earlier as a couple. Force with equal magnitude, opposite direction, separated by a finite distance of 0.4. So this value of this couple will be 50 into the perpendicular distance, that is 0.4. Now, if you see, the turning effect of this couple will be in counterclockwise direction. Alright. So this has to be subtracted. This is negative. Because we have taken the convention clockwise forward. Right? Summation m about O is equal to 180.
But how we can say that it will be anti-clockwise?
See, if you take these two forces, if you just consider these two forces, if you see this vertical arm, it will try to turn it in this direction, right? So this is in what is the clockwise? This is clockwise.
Okay, sir. Okay, got it.
Counterclockwise. So summation m comes out to be 180 Newton meter, and it comes out to a positive value. So that means the moment is in clockwise direction. So resultant is in downward direction, and so we have to find the point of application of the resultant. So to find the point of application of the resultant, what we do, we have to find the x-intercept. So x-intercept. So if you see in the previous slide, the x-intercept is given by summation m divided by fy. Y-intercept is given as summation m divided by fx. Summation fx. So here in this case, the force is vertical, and there is no y-intercept will be at infinity because this force is acting in vertical direction. So x-intercept
Sir,
is
1.8.
pardon?
सर वो जो 100 न्यूटन का जो फोर्स है जो डाउनवर्ड तो उधर -100 × 2 नहीं आएगा?
It will be, see, generally what we do summation fy upwards positive, right? And we apply the sign convention. This will be -100 Newton, correct? So when we are assuming that convention is upward positive, we are getting negative. But here there is only one force to consider. Okay, it is a very simple system because the horizontal forces are cancelling each other. Okay, so that's why I wrote it directly in downward direction. no need to do this convoluted logic when the system is so simple, right?
नहीं सर, वो मोमेंट ऑफ कपल में जो -100 × 2 नहीं आएगा, वो जो मोमेंट जो है
हाँ,
फोर्स इंटू परपेंडिकुलर डिस्टेंस, तो जो फोर्स होता है उसमें -100 × 2 नहीं आएगा, +50 × 0.4.
see this we are calculating moment about point O, right? So if you see this 100 Newton force, this will try to rotate this body in this direction, right? So this will be 100 into 2. So the sense of rotation is clockwise. Okay? If you see this couple, it will rotate it in this direction, opposite. So it is counterclockwise. So both are opposite. So we have taken the convention clockwise is positive. So this is clockwise, this is counterclockwise. So clockwise is positive, counterclockwise is negative.
Okay sir, got it.
Alright, so now calculate the x-intercept, that is summation m about O divided by summation fy.
Sir, can the
1.8.
conventions be changed?
1.8.
For the moment?
Somebody was asking something? Yes, correct, 1.8 meters. Yes, somebody was asking something?
Sir, can the conventions be changed for the clockwise and counterclockwise?
Yes. See, if you change the convention as counterclockwise positive, if you take this as positive, then this will be negative, this will be positive. So you will get -180. So again, you have to finally correct it to clockwise. You can choose any sign convention. You can choose counterclockwise negative also, but the final answer you have to write it without the sign showing the correct direction.
Okay, okay.
Okay. And y-intercept is summation m about O divided by summation fx, and summation fx is 0, right? So y-intercept is actually going to infinity. So this is the vertical force. Okay? And look, so we write the system. Okay? So this is the system, and R is 100 Newton at a distance of 1.8 meter, and it is acting vertically down. So this is 2 meters, so it will be slightly less than that, somewhere over here. This R that is equal to 100 Newton, and this distance is 0.8 meter. Right, so this is the final answer.
सर प्लीज शो प्रीवियस स्लाइड, इसके भी पहले वाला, प्रीवियस स्लाइड. डन सर.
सर
Yes. Yes, go on.
सर आप बोल रहे हो कि वो जो फोर्स है वो टेंड करेगा एंटी क्लॉकवाइज में या फिर क्लॉकवाइज में, तो हाउ टू फाइंड दैट?
See, we are going to find a moment about. Let me clean up. All of you have written down this whole calculation. No? I will just clean up this. So let's just see first. We are calculating moment about. You have selected this origin as O. You can select any point. So for this example, you have taken this as origin O. Okay. So if you see this 100 Newton force, if you see the application of force, it will tend to rotate this object, this P, in this direction. Right? This will be the moment. Okay. And what will be the value of that moment? 100 into 2. Right? So this is clockwise, right? So this moment will tend to rotate the body in clockwise. Now, if you see this couple, this is acting in this left. Top force is directed left hand side. Bottom force is directed right hand side. So this object will be rotated in this. So this is the couple, and this value is given as force into perpendicular distance, that is point. Correct? And this is counterclockwise. Correct? So this couple is in counterclockwise. All right.
Yes, sir.
Oh. Any other questions? Any
So
questions?
that
Yes, go on.
couple, that 15 to 0.4, sir, it should be the perpendicular distance will be less than 0.4 ना, क्योंकि वो लाइन तो उससे पहले ही पास हो रही है ना, जो एक्चुअल डिस्टेंस है उससे.
कौन सा distance?
It is the distance between two couples.
Yeah, this distance between two forces. So this is horizontal. This is also horizontal. All right, they are parallel to each other.
Okay, sir.
Any other questions?
No, sir.
All right. Let's do the next one. Replace the system of force and couple shown in the figure by a single force. So again, you have to find the resultant. So in this case, what will be the resultant? Summation fx. And somebody tell by visual observation, or do we have to do the? So 120 cancels each other. Okay, so this will be result, net effect of that will be 0. All right, so summation fx, if you take right hand side positive, will be 960 cos 60. Summation fy will be 960 sin 60.
Yes, sir.
960. So you actually don't have to do all this because there is only one force, that is the 960. 960. This is 960 sin 60, and this is 960 cos 60, and this is upwards, and this is in the summation fx right hand. So r becomes the square root of summation fx square, summation fy square, and this is 960, and it is at an angle of 60 degrees. Right? Now we have to calculate, we have to find what you say, we have to replace this by single force. So you have to find a location where this resultant is. Okay. So let's take this as origin O, and let's calculate summation M about O.
0, no?
So 0. So this is, let's assume, since I have been assuming as clockwise positive, I will continue to do that. So clockwise positive. So 960 is passing through 0. So moment of that is 0. Okay. So that is 960 into 0 is 0. Okay. But this 120 is there. No?
120 say it will be 120 into 200.
Correct. It will be 120 into 200. Okay. And since this will rotate this disk in counterclockwise. Anti-clock. Okay. So, and we have taken the sign convention as what? Clockwise.
Sir, it would be 120 into 100, isn't it?
No, force couple is perpendicular distance. Diameter is given as 200. So this is 200. Correct? So it will be into 200 and it will be minus. So that comes out to be minus 24000 Newton millimeters. Okay, you can write it in this way also, and it is in minus, so it is 24000 Newton mm, and it is in counterclockwise direction.
Sir, why you took 960 into 0?
No, I mean just to elaborate, this is 0. You don't need to write it like this is obvious. 960 is passing through this origin O, so the perpendicular distance between the 960 and origin O will be 0. Okay, so you don't have to write it, just to what you say, avoid confusion or just for more clarity. Okay. So we have got this moment as 2400. Now you have to place this force is at 60 degrees, right? This is at 60 degrees. you have to find the perpendicular distance between this origin O and the line of action of the force. So how to find out that this is the perpendicular distance, that is summation m divided by r. That comes out to be, just check it, 25 mm.
Sir, please show previous slide.
So d we have to calculate, it is equal to summation m about O divided by r. So that is 24000 divided by r, that is 960.
So why did we divide 24,000 by 960?
We have to find, see, moment is what? Force into perpendicular distance, right? So
Yes,
now
sir.
here we have to replace the force coupled system by single force. So just by finding the magnitude of force is not, we have to place this force in this coordinate system at such location that it will cause a moment of 24,000 Newton mm in counterclockwise direction. Okay, so moment into force is perpendicular. So moment we already know. Okay, we need to find this perpendicular distance.
But
That is,
the distance is also 200 given now.
that is for this 200. This is for the couple. Now we have to going to replace these three forces. That is this 120 Newton force and 960 Newton force with a single force. Okay, so there
Acha,
are.
okay.
So how much is that distance coming out to be?
25 meters.
25 millimeters, huh? Because this is in Newton mm, okay, divided by Newtons. So the answer will be in millimeters, not meters. If you want to find it in meters, then you have to divide this by 1000. That will be 0.025 meters. Okay. So you have moment as 2400 Newton mm counterclockwise, and distance of this resultant from the origin perpendicular distance is 25 mm that we have calculated. Okay. So now this force should be placed in such a way that it should induce a counterclockwise movement, an anti-clockwise, counterclockwise or anti-clockwise movement.
Sir,
At
D is
point,
the distance of
the
distance from
perpendicular
origin
distance
and the
of
resultant of both the forces, na?
the perpendicular distance of the resultant from O. Okay, so I have to place this force now, resultant 960 Newton at an angle of 60 degree, and it should cause a moment of this 24,000 Newton. So I will place it. So this is the resultant, and this is the distance D. R is 960 newtons. This angle is 60 degrees, and D is.
Okay, sir, got it.
All right. All right. So we have replaced the three forces, 120 newtons, this 1, 2, and 3 by a single force. That is the resultant, which will produce the same effect at point O as this combined effect by these three forces. So it is a resultant is 960 Newton force, and it is making an angle of 60 degrees, and it will also generate a moment of 24,000 Newton. All right. So all the conditions are satisfied. 960 Newton magnitude, 60 degrees direction, and a turning effect of 24,000 Newton. All right. All right, we will stop for today. You can go to your next lecture. Any questions before we end?
Sir, please upload the.
Yes, I have uploaded the previous two sections also. You have got it, no?
Yes, sir. Yes.
So I will upload this also today. All right. Okay. Thank you very much. Bye.
Bye, sir.
Thank you, sir.